How'd you get started with 34, Charlie?
4i, and then I did the, like that. And then I did the 1, 0, 13, 0, negative 48.
Awesome. All right, 1, 0, 13, 0, negative 48. Okay, let's just check your synthetic division.
So I got the first part right, but when it came to the second part, I didn't want to start it only because I didn't know how to do the negative 3, 4i times negative 3 would then go through, and so I just kind of stopped it until I got it.
Yep. All right, so just for everybody else's benefit, tell me what you had next so we can just double check the next part. Okay.
And then it went 4i.
4i, okay.
And drop the 4i down.
Drop a 4i down, right?
And then 4i times 4i, that equals negative 16.
Okay, 16i squared, which is negative 16.
Yeah, and then that's 3, negative 3.
Okay.
And then negative 12i, negative 12i squared. Or, no, and then it drops down to negative 12i squared. And then we get the positive 48.
All right, so I get 48i squared, right? But then if you take that i squared, or no, it's negative 48i squared, and that makes 48. All right, and then we get 0. Okay, great. All right, and then you said...
And then you do negative 4i?
Uh-huh. I do the conjugate, so I repeat the process with negative 4i, because I know if 4i is a root, a 0, then negative 4i must be guaranteed also to be a 0. So let's double check that. So we're going to drop down the 1, and then what do we carry over?
Negative 4i.
And what happens?
Does that become a negative 6? Does that become a 16? Or?
No, we're just adding them together.
Oh, and then that becomes 0.
0. Okay, that's awesome when that turns out that way. Okay, yeah, it becomes 0. Then?
Negative 4, then that becomes 0.
0, okay.
And then that becomes negative 3.
Okay.
And then negative 4 times negative 3 equals negative 12i.
There's 2 negatives already.
12i.
12i. So that would become a 0, and then a 0.
You can use
Okay, so I want to reattach those variables at the end. And so starting out with this problem, it started with an x to the 4th. So as I kind of trace my way back down, I'm now at x squared, which is the quadratic formula. Yep. So 1x squared plus 0x minus 3 set equal to 0. So then I'm going to have the quadratic formula. So I'm going to have 0 plus or minus 0 squared minus 4 times 1 times negative 3 all over 2. What do you end up with in the square root?
Well, 4 times 1 times 3 equals negative 12, but that negative in front makes it positive 12.
All right, so I end up with the square root of 12 over 2. So that is 2 rad 3 over 2, and then I kind of want to split that up. So I end up with 0 over 2 plus or minus 2 rad 3 over 2, and that all reduces. The 0 over 2 is 0, and 2 over 2 is 1, so I end up with plus or minus rad 3. So those are my last 2 zeros. So if I were making a list of all my zeros, like if I were doing my cycle, my zeros were 4i from the beginning, negative 4i from the conjugate, rad 3 that I just got from the quadratic formula, and negative rad 3. So my job then is to, they asked me in 34, write all the factors. Okay, they call it linear factorization. It's just a fancy word for all the factors. So there will be 4 factors, 1 for each. So you'll have x minus 4i, x plus 4i, x minus rad 3, x plus rad 3.
Can you just do x plus minus rad 3?
No, they have to be separate so that you get 4 separate ones. We're going to take an open quiz tomorrow, and it will likely be like this. It'll be one problem, right? And it's just going to be one problem. You got to do the imaginary synthetic division and work your way. Probably be like something like 35 or 36, but 34 is similar also. Okay? Yeah, Trav.
Could you also do, because you got 1x squared plus 0x plus 3, can't you also, since there's only one x term, just x squared plus 3 and just...
That would also work. Sure. Okay, 36. What did you start with on the outside, Brandon?
I tried to, I saw it, I just, because I don't know how to do the 1 minus 3i.
And so where does the 1 minus 3i go? Okay, so that's what goes on the outside. 1 minus 3i. Okay, what goes on the inside?
1 negative 2
1, negative 2, 5, okay, so we did a sample like this in class. Did you not have your notes to refer to?
I did, but I'm still confused.
Okay, all right, well, let's walk through it together. What do you drop down first?
1.
Okay, what do you do with that 1?
We multiply.
Okay.
1 and negative
All right, so I get
1 and negative
1 and negative 3i, okay. All right, and then what drops down from there?
1 minus 3i.
Right, so the negative 2 and the 1, they go together because they're both integer terms, so that gives me negative 1, and there's the negative 3i is unaffected. Okay, now what?
And you gotta multiply that to 1 minus 3i.
Yes, so I've got to take, right, and I've got to take this and multiply it by what's on the outside, and that is going to take FOIL for that to happen. Okay, all right, so are you ready for that? We can do FOIL. So I'm just going to slide my work over here a little bit, and I'm going to do my FOIL on the side. So if you had a margin or somewhere on your paper, where that's what you would do. So we're going to take 1 minus 3i, and we're going to multiply it by negative 1 minus 3i. Okay, go for it.
So negative 1 and negative 3i, and positive 3i, and positive 9i squared.
Positive 9i squared. Okay, clean that up a little bit.
And negative 1 minus 9, so negative 10.
Okay, so it's not too bad. It worked out to be negative 10. So now I'll slide my work back over, and it's going to be negative 10. Okay, so what do I drop down?
Negative 4.
Okay, and what do I do with that negative 5?
Negative 5 plus 15.
Oh, it's not working. Okay, so I get, when I distribute, I get negative 5 plus 15i. Okay, and so now I'm going to drop those down, and remember, we're combining the integer terms together. So what will I get?
Negative 5. Well,
5 plus 15i. Okay, and what do I do with that? 5 plus 15i.
4.
Okay, so I'm going to slide my work over, and I'm going to do my FOIL out on the other side over here. So I have 1 minus 3i FOILed with 5 plus 15i. Bless you. Okay. All right, so what do I get? 5
15i
plus 15i,
negative 15i
negative 15i,
minus 45.
minus 45i squared. So clearly the 15i's in the middle knock out, but what do I get at the end then? I get 5 plus 45, and I work out with 50. So I'll bring that over to my synthetic division, and it's a good thing I got 50, because that allowed me to get 0, which is what I needed. Okay, I promise the first round of synthetic division is always the hardest. The second round of synthetic division is always like, whoo, it just is going to drop, 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 drop. We're going to have stuff canceling out all over the place. But when I do my second round of synthetic division, what am I doing it with? The conjugate, which is 1 plus 3i. Okay, so, and I promise this will come out easier. So drop the 1. All right, and then what do I carry through? And then what happens when I've got a 1 plus 3i underneath something that's already negative 1 minus 3i? Okay, great. So I told you it would come out to be easier. Then we multiply by 0, and that just makes negative 5. And then I take that negative 5, and I multiply it by 1 plus 3i, so that'll be negative 5 minus 15i, which for sure gives me 0 again. So it always should work out that way, that it simplifies. And if it's not, Brandon, then something in what at the first round, you lost a negative, or made a careless something went wrong. If you're not getting an easy 0 the second time through. Okay, now you're to the point where you're going to reattach those variables. So onto that, that'll be a 1x squared and a 0x minus 5 equals 0, and you can solve that any way you see fit. Okay, you can solve that with a quadratic formula, or star doesn't work, but any other way you want to solve. Okay, after you're done solving it, you're going to get the solution. X is plus or minus rad 5. So to summarize what we've got, if we're picturing our cycle, the zeros, we showed 1 minus 3i to start. We showed 1 plus 3i as our second round of synthetic division. From the quadratic formula, we got 2 more, which then leads me to be able to write my final factors. So a factor for each. So in that funny factor where it's 1 minus 3i, how do you write that as a factor? X minus 1 minus 3i. So it still has to start with an x, and then x minus 1 plus 3i. So those first ones, those factors, have 3 parts to it: an x part, an integer part, and an I part. And then x minus rad 5 and x plus rad 5. So I'd say that is the most similar to the open quiz tomorrow. It'll be one question. You get to do the whole thing. I'll give you an imaginary root just to check that you can do synthetic division, that you can do the superfoil, that you can do what you need to do to be able to get that. All right? Good. Yeah, Brandon.
27.
Sure. Okay, 27. You're going to need your graphing calculator if you don't have that out. All right, so can you type that in to your graphing calculator already? All right, number 27. Okay, while Brandon's getting a graph of that ready, we are starting in our cycle with the polynomial of 27. They gave us x to the third plus 4x minus 5. So if you were thinking about we could either go right to the graph or we could go directly to the factors. At best, when you make a graph of this, the best outcome would be it crossing how many times?
3 times.
3. Okay, that would be the best outcome for me to see it crossing 3 times. What do you see on your graph? Crossing once. So what does that tell me about what I don't see? Any ideas? No? Well, sometimes it could be that the graph is too small, but not in this case. Anybody else have an idea? At best, he would see 3. He's only seeing 1. How do you explain the difference? How do you explain the discrepancy? They're imaginary. The rest of them are imaginary, so you're not going to be able to see them. Okay? So what our graph is showing us is we need 3 total. We have 1 real, which leaves 2 imaginary. So at least let's start with our 1 real. Okay, what is the 1 real that you see off that graph? Is it a half? All right, so we're confirming that the 1 real that the graph is showing us is the number 1. What do I do with that? Okay, I'm going to use synthetic division. So what are the numbers I'm working with on the inside of my synthetic division?
0, 4,
Okay, 1, 0, 4, negative 5. So I should be able to confirm that that turns out to be 0 pretty easily. It didn't, like, it's nice when you don't have to work with imaginary numbers, at least at this stage in the game. All right, now we're going to reattach our variables back onto that. So that'll be 1x squared plus 1x plus 5. And that equals 0. And then we'll use the quadratic formula on that one. So negative 1 plus or minus the square root of 1 minus 4 times 1 times 5 all over 2. So I'd be pleasantly surprised, but I'd be very surprised if anybody actually had gotten this one right on the first try on their homework. Because you end up with negative 19. So what do I do with that negative 19? Okay, take an I out. So that would be negative 1 plus or minus I in front of the positive 19 now. And then you want to separate that. And so negative 1/2 should come first. And then I rad 19 over 2 would come second. So my zeros right now are the one that you saw off the graph. Remember, we had 1 real and 2 imaginary. And so my 1 real was 1, and my 2 imaginary, negative 1/2 plus I rad 19 over 2, and negative 1/2 minus I rad 19 over 2. Okay, and what what would be, I don't know, maybe I'm selling you guys short, maybe you got it right the first time, but usually what happens is people write their factors like this, x minus 1, and they write their second factor as x plus half plus I rad 19 over 2. And then they write their third factor as x plus half minus I rad 19, if they got that far. What usually happens that people miss is that they forget that factors can't have fractions in them. Okay, factors can't have fractions. So how do I clear out the fractions? Do you remember how to do that, Brandon?
That would be like 2x.
I think, what do you mean? You get 2x. How do you magically just get 2x?
Like it's over a half, so you just multiply the whole thing by 2.
Okay, so we're going to multiply the whole thing by 2. That's what we want to do. So x minus 1 is fine, but then we're going to take these fractions and or factors, and we're going to multiply them all by 2. And then we do that for the second one also. And what that does is it gets rid of the unwanted fractions for me. So I'll have 2x plus 1 instead of a half, and then plus I rad 19. It's not over 2 anymore. And then 2x plus 1 minus I rad 19, and that's not over 2 anymore either. So I doubt anybody got that right, but if you want to, brag about it and you got it right, yeah, then
Yes, I